Okay, today we're gonna talk about series. So, actually not series, power series. So let me change that. Power series. And so basically a power series is a series that looks like this. The sum as n goes from 0 to infinity, Cn times x minus a raised to the n power. The first term right here will be C0, then C1 times x minus a plus C2 x minus a squared plus blah blah blah. My students like the blah 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 thing. Alright, let's go ahead and start with a geometric power series. So that would be a power series of the following form. If you take x to be 0, and all these coefficients, C0, C1, and all that, those are coefficients. So if you take all the coefficients to be 1 and a to be 0, then you get this series. This series right here can be written as 1 plus x squared plus x cubed plus blah blah blah. And this is equals to 1 divided by 1 minus x. In other words, this series converges to that function as long as x in absolute value is less than 1. This is the same as x between minus 1 and 1. Alright, let's see, another power series that would be sort of like a geometric series with center not necessarily at 0 would be these kinds of series, something like 1 minus 1 half x minus 2 plus 1 4 x minus 2 squared plus blah blah blah. This series can be written as the sum as n goes from 0 to infinity, and the nth term of this one, I didn't write it down, but it's basically minus 1 over 2 raised to the n power, like this, times x minus 2 raised to the n power. And when you write it down, this is just the sum as n goes from 0 to infinity of minus x minus 2 raised to the divided by 2 raised to the second power, into the n power, with this minus sign here inside this parenthesis. Okay, this will converge to 1, which is the first term, divided by 1 plus x minus 2 divided by 2, which, if you like, it can be simplified to 2 over x. In other words, this series converges to this function 2 over x. On what interval? On the interval where the radius, which is in this case minus x minus 2, so when the radius in absolute value is less than 1, so in this case that would be whenever this is, so this is equals to minus 1 times x minus 2 divided by 2, and this is just x minus 2 divided by 2, and you want that to be less than 1. So that means in this particular case, this series converges to this function whenever x minus 2 in absolute value is less than 2 by multiplying this by 1. And that's the same as saying that x minus 2 is less than minus 2, less than positive 2. So let me raise that negative. And less than negative 2, and then if you add 2 to both sides, you get that x is between 0 and 4. So this series converges to this function from 0 to 4. These are geometric power series. In general, we don't have geometric power series, we just have a power series, and we want to know where the series converges. A series converges to a function, or sometimes only just to a number, at the center always, and then it might converge away from the center. So suppose we want to find out the values for which this series converges. So we have the series that goes from 1 to infinity, and this series is minus 1 like this raised to the n minus 1, x to the n power divided by n. So this series is going to converge to some function, and we're going to find the interval for which it converges. To find the interval for which it converges, we're going to take the ratio, or use the ratio test. So in this case, the ratio test would be u sub n minus plus 1 divided by u sub n plus 1, u sub n. This would be x raised to the n plus 1 divided by n plus 1 times n divided by x raised to the n power. And when you simplify that, you just simply get n divided by n plus 1 times x, like that. And then you're supposed to take the limit, because you're using the ratio test as n approaches infinity. And when you take the limit, you get x, because the limit of n divided by n plus 1 is 1. And you want that to be less than 1 for absolute convergence. So then the ratio test tells you that for sure this series converges to some function from minus 1 to 1. The problem is we need to check the endpoints. So we're going to check x equals 1, and then we just get the series from 1 to infinity. We get the minus 1 raised to the n minus 1. We plug that 1 where x is, and then we get this. And this just gives you the sum as n goes from 1 to infinity of minus 1 raised to the n minus 1. 1 over n, like that. And this is just the alternating harmonic series, so this is convergent. So that means that the series is going to converge at x equals to 1, which is the right endpoint. Then we have to test the other point, x equals to minus 1. So that will give you the series that goes from 1 to infinity, minus 1 raised to the 2n, I'm getting ahead of myself. Let me raise this to n. Just n minus 1, and then we're going to plug minus 1 for x, like this. And then we get this series that goes from 1 to infinity, minus 1 raised to the 2n minus 1, like this, 1 over n. Because 2n minus 1 is a odd number, this series is just nothing more than the negative of the harmonic series, and this is an infinite, or this series diverges, which means that the convergence to this series to a function is just on the interval from actually from minus 1, not including minus 1, all the way to 1. So you include 1 and not minus 1. And then we also have something that is called the interval of convergence, and that interval of convergence will go from minus 1 to 1, excluding minus 1, that's what the parentheses mean, and including 1. Next scenario, you could have a series that kind of looks like this. If you have a series that looks like the sum as n goes from 1 to infinity of x to the n power divided by n factorial, and this series converges to something, to some function, we want to find the values of x. So use the ratio test. Like that, you take that and absolute value. This is x to the n plus 1 divided by n plus 1 factorial times x to the n power divided by n this is n factorial divided by x to the n power. Anyway, this is x to the n plus 1 divided by n plus 1 times n factorial. When you reduce that factorial, n factorial x to the n, like this, the n factorial cancels with this, and then you just get 1 over n plus 1. Let me just put it right here. So you just get 1 over n plus 1 times x in absolute value. And that goes to 0 no matter what x is, so for all x. In this particular case, we get that the radius of convergence is equals to infinity. The center of this power series is 0, and then the interval of convergence goes from minus infinity to infinity. And then sometimes they say, okay, write the solution down or graph the values for which this series converges for what values of x. So they just put from minus infinity to infinity, and then they just kind of go like this. Okay. All right. The next scenario that can come up would be the following. If we have this series that looks like this, n factorial times x to the n power, and we want to find for what values of x this series converges. Using the ratio test, you got use of n plus 1 divided by use of n in absolute value, and then this would be n plus 1 factorial times x to the n power divided by n factorial. This is x plus 1, this is xn, like this. And this would be n plus 1 times n factorial times x to the n plus 1 divided by n factorial, x to the n, like this, like that, and then this n factorial cancels with that, and this time you get n plus 1 times x. And then you take the limit as n approaches infinity, and you get that this is infinity unless x equals to 0. And in this case, you get that the radius of convergence is equals to 0 because the series only converges at x equals to 0, so there's no radius of convergence, or the radius of convergence is equals to 0. And we say that the interval of convergence is just the center, so in this case it's just 0. And when you graph the solution where this series converges, it converges just at 0, so that's why this little dot only. Okay, I'll do another little lecture about more properties of power series and blah blah blah. Thank you very much.